Hello everyone. So my name is Yong Yong, and my title of my project will be Autonomous Non-Conforming Lot Analysis and Disposition using Machine Learning. So a quick reminder. So what are these non-conforming lots? Non-conforming lots come from wafers. Wafers are non-semiconductor materials that are used to produce chips, as you know, from chips like Intel chips and whatsoever, those silicon chips. Yeah, so my job would be producing a system that would classify whether a lot would be bad or good based on the data set given. So that is just a brief introduction. So firstly, the problem statement. So currently, this is a project for ST Microelectronics, and the problem they are facing now is they are highly dependent on the test engineers to analyze and disposition of the NCL. Next, the company has to hire many test engineers just to perform these specific tasks, which could be costly. And lastly, the whole process of testing and disposition for the NCL is very time consuming. Why the reason why is because they have to perform like hundreds of tests just to ensure that these lots are fully functional, because these lots are very fragile, and even during the process of building it or even exporting it can harm it easily. So the objective of this project would be to build a non-conforming lot classification model using AI techniques, and lastly develop a dashboard to display the NCL classification, analysis, and disposition. By the way, NCL is a non-conforming lot, which is a defective lot. So this is a simple architecture of what I have done. So the dataset is given by ST Microelectronics. So the first two dataset will be the defective. This dataset we are given 7 dataset, and all of it are combined into one. But the first two files of the dataset will be the defective parts containing the data and whatsoever, and the third until the seventh file would be the lots that are that are running perfectly well. So I'll just quickly scroll through. So for feature selection, just want to clarify that there are a total of 127 features and 26,000 data in the dataset. So what we do is, firstly we remove all the data that is not useful, and lastly is the part where is feature selection. For feature selection, we'll be using random forest, and the random forest it generates 186 data sets, which from 1027 features to 186 is a pretty good result. So next we'll be building the model. The first model we make is neural network. We will be comparing neural network as well as the SPM to check which one has the better accuracy, and we found out that this one has the better accuracy, which is we'll find out later that SVM has the better accuracy. So as you can see, neural network has accuracy of 0.65 and 68 roughly, and SVM, here is the score for the SVM, which is a very good result. So we'll be moving forward to using the classification model using SVM. So here are the confusion metrics and the ROC curve, which further signify that this is a good model due to its high value of ROC AUC, as well as the confusion metric, which is pretty accurate based on what you've seen there. Next would be the dashboard. So why be using dashboard is because basically it is used to communicate significant trends and issue and insights for non-technical users. The non-technical users would be so-called the workers in ST Microelectronics, because obviously they don't have much knowledge on AI, so it's our job to make it easier for them to understand. So this is the dashboard. As you can see, the scatter plot here is pretty well, wouldn't say well done, but it has a high correlation value. These are the at the end of the day, we found out there is a total of 1, 2, 3, 4, 5, 6, 7, and yeah, 7. These are the few variables that will be useful for our things. So that's all.